quiz 4 from this spring. So again, here we have a ketone and an ester. We got to think about these two things reacting. Ketone is going to react first. This is lithium aluminum hydride. It's an excess because the ketone is more reactive. This has resonance, which makes it less reactive. H- reacts there, kicks up, makes a tetrahedral intermediate. There's no good leaving groups. We're done. We keep the minus charge. We do not mix the steps. Do not mix the steps. Another H- comes in, adds in, tetrahedral intermediate. You have a good leaving group. The O- comes out, stays in O-. Another H- comes in, reacts with the aldehyde, kicks it up, makes a tetrahedral intermediate. Now we have no more good leaving groups. Now we do the 3 times protonation, and we get to the alcohol. A lot of folks, first of all, they react to the ester first, which you shouldn't. You should react to the ketone, the more reactive thing first. And they also tried mixing these steps up. Or they got here and forgot to do the elimination, the tetrahedral intermediate, and kicked that down to do the elimination. That was the big goof in that one. This one's pretty straightforward. Mechanism and product. So we have a asymmetric center. Well, actually, it's not an asymmetric center. I look at it. No, this is not an asymmetric center, but you would do an inversion, I guess we could say. Oxygen reacts there, kicks out like an SN2. Bromine comes to the backside, but because it's symmetrical, actually it's not asymmetric. No carbocations. This is one of the ways to activate alcohols. Without carbocations, we usually get inversion if there's a stereochemistry, a stereo center there. So most people got this right. They did a good job. So again, mechanisms and products for the reaction below. So magnesium, remember it's that radical process. I saw a lot of people doing double-headed arrows or all sorts of things. Radical process, right? The magnesium gets oxidized, goes from magnesium 0 to magnesium 2. So there's 2 new bonds. Right, this is one of those fish hook arrows. So make the Grignard. Grignard reacting with an epoxide, it's a basic condition. When you're in basic conditions with epoxides, you go to the less substituted side. So it adds in there again like an SN2. So we added the 2 carbons, popped open the epoxide, and a little bit different here. Usually we have H+, but instead I threw in a different electrophile. So if you make O-, O- is a nucleophile, and then you can add in really any electrophile you want. We usually do H+, because it's just easy. But here I just added in a different electrophile. So you just do another SN2 and add a 2 carbon piece. And then you get to this right here.